Hi, in this notebook, we'll explore advanced techniques using Tiny Llama, a compact but powerful language model. We start by setting up our environment with essential libraries like transformers, PEFT, and bits and bytes. After confirming GPU availability and setting random seeds for reproductive stability, we define our configuration parameters. Tiny Llama 1.1 byte chat is our base model with a default context size of 512 tokens and an extended context of 2048 tokens. We have configured LoRa parameters with a rank of 8, alpha 16, and dropout of 0.05, targeting key projection layers in the transformer. In section 1, I explore the chat template structured format for conversations. We initialize the tokenizer with support for chat templates and create a custom template that clearly identifies different roles such as user, assistant, and system. This formatting is crucial for conversational models to understand the flow of dialogue. We load our base model with 4-bit quantization to reduce memory usage and apply LoRa for parameter efficient fine tuning. And moving on to the section 2, which focuses on conversational chat fine tuning using the Anthropic helpful harmless data set, we process the data into a format compatible with our chat template, splitting it into training and validation sets. We then tokenize the conversations and set up a training pipeline specifically optimized for dialogue interactions. In section 3, we then demonstrate classifications with chat templates using the movie review data set. We frame the sentiment analysis as a chat where the system instructs the model to classify the reviews. The user provides the text, and the assistant responds with positive or like a negative. This clever approach lets us use the same chat format for classification tasks. And then moving on to the next collab, here I will be using the Unsloth library, focusing on efficiency optimizations for smaller models. We start by installing specialized packages including Unsloth, which provides optimizations for efficient fine tuning of language models. We set our context length to 2048 tokens and enable 4-bit quantization. Despite the comment mentioning the code actually uses OPT 125M here, then the training configuration uses a small batch size with gradient accumulation, 1000 total training steps, and mixed precision training for efficiency. After training, we then save the model for later use. And then moving on to the next collab. Here we begin with simpler setup steps, installing the Unsloth library and its dependencies, and then the LoRa is applied with a rank of 16 here, which is actually targeting attention and feed forward layers. For training data, we use the Alpaca data set, which contains instruction input output triplets ideal for instructions tuning. We format this data using a template that clearly delineates instructions inputs and desired outputs. The SFTT trainer is configured for supervised fine tuning with an effective batch size of 8. After just 60 training steps, the model is prepared for inference and tested with a simple question about Paris landmarks. And moving on to the next collab here, we start with similar dependencies installation, then load Gemma 2B with a context length of 2048 tokens. For dataset preparation, we load Squad and apply tokenization. The code includes a formatting function that handles the complex structure of the dataset, extracting context passages, everything into a clean context question answer structure. LoRa is applied with similar parameters as previous notebooks, but with a slightly higher dropout rate of 0.05 to reduce overfitting. The training configuration is set up for 100 steps with a learning rate of 2e minus 4 and linear scheduler. And this is how it demonstrates how to adapt a model for a specific task like question answering, highlighting the versatility of these fine tuning approaches.